Hello. Hello everyone and welcome to the 16x model evaluation stream. And yeah, welcome everyone. And today we'll be evaluating a not so new model, GLM-4.5, which was released, I believe, actually a while ago. That's actually like almost 2 months, one and a half months ago. The reason why I'm only doing it now is because there are so many new models that I didn't get a chance to do for this one. Yeah, but anyway, let's try to do this now since people are coming to realize that this model is actually pretty good. So yeah, reasoning, coding, agentic. Okay, so some pretty standard wording here, similar to Kimi and Quantry Coder. And this GLM 4.5 is available on OpenRouter, of course, with a lot of different providers. I think the pricing is quite competitive. Hi, hello Nathan. Yeah, I think more or less everyone have the same price, looks like. And the reason why this model is getting a lot of attention is because they recently released the GLM coding plan, which is like a competitor to Claude Code. And how it works is that you subscribe to this plan and then you can use Claude Code as in the coding tool, but connect to the Z.ai backend and basically for cheaper price. So you access GLM 4.5 instead of Sonnet and Opus models, and it's about the same. I think it's about the same like usage, or maybe a bit higher, but it's much cheaper at $3 per month instead of $20. So yeah, so this is what got a lot of people excited. And today we'll be testing out this model to see if it's actually any good for coding. So far, based on the feedback, I think it's kind of okay. So let's take a look at the leaderboard. If we go to leaderboard and organize by programming, I think there's a way to organize by programming, but I can't figure out. Oh yeah, this one is by programming. And if we look at the top models, you can see GLM 4.5 is at number 16, getting a little bit outranked by the newer models like GlucoFast 1, which we just did an evaluation on recently. So if you want to look at that, you can look at the previous live stream we had on Gluco 1. And it's also outranked by Quantry Coder. Yeah, so it's not very highly ranked, but rumors are that it's a very good model, so we're gonna test it out. Anyway, I think let's get started. So that's the model, and we've already covered what it is. So let's cover how do we do the evaluation. So as the standard evaluation applies for all the 16x evaluations, we will use the all default parameters. That means for reasoning, for verbosity, for temperature and all that, we'll use the default parameters. And for each task, we actually have a rubric. So let me go ahead and open up the rubric. So you can see here we have all the tasks here, and for each task we have a rubrics that specifies how do we evaluate the response of the model, and me as a human evaluator will assign the score for each model output. For example, here, I will assign the rating for each output on the order scale of 0 to 10. That's how we give the score for each model. Yeah, so basically that's how we do the evaluations, and we have 7 evaluation tasks. So this is something that I've been working on, and we're trying to expand how many tasks we have. So currently we have 7 different coding tasks, and this is the list of them. You can also see them on the right side of the screen. So this is directly synced to the stream plan on the right panel. You can see where we are right now. A note is that all 7 evaluation tasks are based on real-world coding tasks. So these are the coding tasks that are collected by myself and curated by myself to mirror what a typical developer would encounter. In fact, I think most of them are kind of based on the real tasks that I've encountered, and I just package them into a task for the model to solve. So yeah, so these are real world tasks, not a synthetic benchmark. Obviously, it's not as comprehensive as a benchmark that have hundreds of problems, but I believe it's still a good evaluation to have. So each model will have their rating on a scale of 1 to 10, or 0 to 10, instead of just a binary, pass or fail. So that's kind of more nuanced. Yeah. So without further ado, let's maybe introduce a bit of how we're gonna do the evaluation. So I have a app here that I built myself just for running the evaluations. So we can run all the evaluation through this app, and it's connected to different models. Let me hide these some of the unnecessary columns, so you can see. Yeah, we'll be using this app to run all the evaluations for today. And let's start with the first task. So the first task we're gonna run is the Tailwind CSS v3 z-index task. So I'm gonna run this task first and then explain what this task is. So I'm gonna create a variation and select the model. Oh yeah, so we'll be using GLM-4.5 via Z.ai, which is the original provider, but we'll do it through OpenRouter. So yeah, let's run it. So this task, Tailwind CSS z-index, let's take a look at what it does. So it's basically a task that tests the model's ability to solve a bug on Tailwind CSS. So this is the full prompt. We can see there's a HTML file that contains a bug. So the bug inside this HTML file is actually to do with the z-index. So if we open up this file, click this, we can see the setting button is blocking the model. That's because so if we go back to this file, there's some invalid z-index here. For example, z60. So these are the invalid classes inside Tailwind CSS v3, and they are only invalid inside v3, so this wouldn't be a problem in v4. And the model knows that we're in v3 because of this CDN URL. So we'll be testing the model's ability to handle a specific version of a library and a very specific bug with Tailwind CSS v3. So far, all the top models were able to solve it. So So I don't know if this one can solve it, but I think it should be possible. Also to note, I think this is a reasoning model, so it's gonna take a bit longer for it to generate a response. Let me check. Yeah, so it should be working. It's just taking a while to generate. We're back to GPT-5 speed. Surprisingly, this is actually quite long. I would expect it to finish by now, but it's still running. Maybe I can share a bit more on the current evaluation result. So as we can see, we have the current top models. Opus is the top, and GPT-5 on high reasoning is second. And all the open source models except for GPT-OSS 120B is actually a bit lower on the ranking. So I have Venture Coder here, Kimi K2 here, and DeepSeek V3 3.1 here. And I would expect GLM-4.5 to be somewhere around this range. Yeah, I would expect it to be quite similar to Google Code Fast 1. But let's see, right? Maybe it's actually much better. It's still running. Okay. Oh, that's very slow though. Okay, that's gonna be a big blocker for some people. That's actually very slow. Now, lucky for the people who are watching the replays, you can skip this part. Okay, so maybe it's just the provider, right? So let me check the providers. Maybe just this provider is very slow. It's 34 throughput. Okay, that seems reasonable. Everybody seems to be around the same range, not something much faster. So we just stick to this one. Okay. Is this still thinking? That's quite a lot of thinking. That might be the longest wait I've had, or maybe my code has some bug. Not sure what's the reason. Maybe I should have streaming like a token indicator. Okay, unknown error. That's a bit weird. I don't think I've seen that before. Let me check if I can see it on. Yeah, I can't see it in the activity as well. I don't know what happened, but let's try again. I've tested it before this stream, so this should work. There's no reason why this doesn't work. So maybe just now there's some bug, right? I think this one was quite fast, 42 tokens per second. Yeah, let me know if you have any questions on how this works, or how's your experience with this model. Yeah. Yeah, I think I should add a more interesting progress indicator for this, or like, yeah, I think I'm thinking of maybe I should put this evaluation into the background so that I can run multiple evaluations like at the same time instead of being stuck here. Yeah. maybe I'll do that tomorrow, and then for the next stream we'll have evals running in the background in parallel. Yeah, this one currently the app can only run, it can run evals in parallel but cannot run for different experiments. So yeah. Oh, I have specified it to go through the Z.ai provider, so there's no slow or fast, it's the fixed provider. I don't want the different providers to provide different results, right? So all the providers are fixed, so this is going to Z.ai. Well, on the other hand, yeah, maybe open router load balancing is not very friendly to hard-coded providers, so that might be the reason why. That's slow. Yeah, I think it's slow, but it's not that slow. Like it's 34 tokens per second. Shouldn't be that slow. Oh, I think it has some issues recently. And the latest one is NA. Okay, let me see if NA is, oh yeah, I think NA is the expected behavior. Yeah, okay, so this is not going very well. Oh wait, it finished. Okay, so it took 160 seconds and it finally finished. I think I can also check the reasoning effort. Reasoning tokens here. So if I open the reasoning tokens, I can see it consumed 7,000 tokens, which is a lot. Yeah, it's more than GPT-5 and almost as much as Grok 4. So yeah, so let's, yeah, that's very slow though. Like, I don't know, can you disable reasoning for this model? I don't think you can, right? I don't think you can disable reasoning. Oh, you can disable reasoning. Okay. It looks like you should be able to disable reasoning for this model. So there may be a way to make it faster, right? Yeah. Yeah, look at the usage. I think people are using it with reasoning tokens. Let's see. Anyway, I have a script to automatically check what's the output look like. So I'm just gonna copy this and put it here. Maybe I'll just remove this, copy the code here, and then I have a script to check the progress. Okay, so it actually did not fix the invalid classes. Okay, that's interesting. So let me check what's the actual model output. Okay, so the bug is related to the display state management. Okay, interesting. So that's the completely wrong diagnosis. It didn't even find the what the bug is. It didn't identify the bug is to do with the Z60 invalid Z index. So so yeah, this is a complete fail. Not identified. Score 1. Okay, so it got a score of 1. Not identified, but for this task every model gets 2 tries, so let's give it a second try. Interesting, it's not off to a very good start, but to be fair, Grok fast also didn't get it right? So Grok fast also got pretty bad. If I look at the results for this task, so all the top models got it right. And then on the bottom, we have all the open source models that got it wrong. So Grok Fast got it wrong, DeepSeek v3.1 got it wrong, Quandric got it wrong for 1 time, and then got it right the second time. But the time where it got right actually it provided the wrong explanation, so it's not a good answer as well. Kimi K2 also got this wrong. So basically, this task is where all the open source models struggle a lot. I think the only open source model that got it right was GPT-OSS 120V on Cerebrus, which got it right. Yeah, so this is the task that actually differentiates open source model with the the good model with the bad models. So this time it took significantly less thinking tokens, only 1,200 reasoning tokens. So that's interesting. So let's see the output. Okay, looks like the explanation is also wrong. That's not very good. So let me just copy this to my evaluator. Get this response on this test. Okay, yeah. So basically, it also didn't find the invalid class, so that was also wrong. We get not identified as the remark and 1 for the score. So that's the first task done. Let's see how well this model ranks. So I'm gonna select the model and maybe I'll remove GPT 4.1 for now. So you can see it's not doing very well. It's not doing very well. So let me remove Grok 4 and show the next best reasoning, next best open source model, which is Grok Code. Oh, sorry, Quantry Coder. Yeah, let's compare it with Quantry Coder. I have Quantry Coder here. Sorry, it's not this one. I have the other Quantry Coder. This one. Okay. Yeah, so Quantry Coder got it right despite the wrong explanation. So yeah, so the first task is not very well for the GLM model. Let's try the second task. Okay, so the second task is called clean Markdown. I'm gonna still run it first, and then we'll explain what it is. Let's try to run this with GLM. Okay. Yeah, so the second task is a task that tests the model's ability to kind of write TypeScript. Yeah, so the requirement is to write a TypeScript file that cleans Markdown into a plain text. So that means the code has to do the following: unwrap the code blocks, unwrap the links, replace headings with plain text, remove all the tables and components and all that. So for example, given a sample input like this, we would expect the model to output a sample output like this. So basically remove all the Markdown syntax. So that's the prompt. And then for the rubrics, so basically we'll check if the output is what we expect, and then we have some penalties for the new line issues, and yeah, so that's basically it. I don't think a lot of models will struggle with this, but let's see. Again, this is quite slow. Let me check my open router activity. So we can see here we have the provider routed to Z.ai, and the speed is actually pretty fast. So yeah, it's just the reasoning tokens that is taking very long. I believe if you use this model inside a client, the default, let me check what's the default if you use it inside client, right? So let's say you go to open router and then choose this model. Is it enable thinking? Oh, it doesn't enable the thinking by default. Oh yeah, so looks like it doesn't actually enable thinking by default. So I guess people are using it without the thinking. Yeah, I'm not sure, but thinking mode should be able to give you a better performance, right? So we should still be testing with the thinking mode enabled. Looks like this model by default will use thinking, and it's not like you need to enable it. Yeah, there's no specific disabling of thinking here. Yeah, so we're just using the default parameters, so that means it has thinking enabled. And again, we hit some error, I think. Didn't get a response, so let's try again. This is becoming very annoying. I don't know why it's giving me errors. And there's nothing on the OpenRouter dashboard as well. I think if there's an error, it should show up here, but it doesn't show up here. That's very weird. I'm pretty sure my request was sent out. I mean, because if it doesn't send out, I will get an error immediately, so it must be processing. But somehow I don't get a response, so yeah, there's something wrong with OpenRouter here as well. It should at least log an error, right? Or maybe it just doesn't show the generations that errored. Okay, anyway, we can look at the result for this task. So we are at clean Markdown. This is a medium level task. You see all the top models got it right. And yeah, so basically all the models did pretty well on this task. I guess GPT-OSS 120V surprisingly did pretty relatively worse. All the other models got it right, I think. Yeah. Okay, again, unknown error. Oh, this is the first time in running so many evaluations that get so many errors. Let's try one more time. I don't know. I mean, if we get error for this task, then we might get error for the next task, right? So okay, I think I might know why I'm getting error. I think I might know why. Because the company released this coding plan, right? So technically, a lot of people are trying to use this model for like inside Cloud Code. That's why maybe there's like an increase in demand. That's why the provider Z.ai is not able to provide enough capacity, right? I think that's a good explanation for what might be happening here. So by the way, I want to test the model with the Z.ai provider because I want to test the inference served by the original model creator. I don't want third-party hosting provider solutions because you know, they might have some bugs in serving the model. So given the choice, I will always use the original model creator. So that's why I'm just using Z.ai, not other providers for this model. But it's actually very slow, and here it says the uptime is 99.86, so I must be unlucky, right? Yeah, I must be unlucky for this model to be this slow. And let me write my notes here. So very slow. Okay, actually, let me write my notes on my YouTube. So this is slow, failed, slow, and 2 errors, 2 error cause. Yeah. I'm thinking if they're having a lot of errors and slow serving, then maybe this model wouldn't be popular anyway, because they don't have the capacity to serve it, right? Like if you make it $3 a month and then you don't have enough capacity to serve it, then it's quite useless, right? I guess. Yeah, I mean, if anyone is using GLM 4.5 inside Cloud Code, maybe you can share your experience. I don't think this speed is acceptable, like especially with the errors. I don't know what exactly is the error, but I'm assuming it's just cut off halfway, and I can't see the logs on OpenRouter. So that must mean the provider has errored. I don't think it's a bug with my app, because I've never seen this error before, and it works for some of the prompts, so it must be from the provider side. Okay, I thought the GPT-5 high was slow, but now I understand which one is actually slower than GPT-5. GPT-5 on high took 276 seconds. That is like almost 5 minutes. And I think this one already took longer than 5 minutes because of all the errors. Oh, okay, finally finished. See, 300 seconds, and okay, 18,000 thinking tokens. 18,000 thinking tokens. That's crazy. Let me double confirm. Yeah, it is right. So there's a bug here. So the reasoning tokens is higher than the token completion. There's a bug here, but 18,000 reasoning tokens. Let's see. So this is the reasoning token. I'm not gonna read it, but just to let you know how long it is. Okay. I don't think this is normal. That's still going on, still going. Okay, now I understand why it's so slow. That's a lot of thinking tokens. Okay. 70k characters, 10k words. Okay. Okay. This is just a medium level task though. I wonder how long it will take for the next task. So let me get this and try to run it. Clean Markdown model response. So we have sorry, GLM-4.5. Okay, this better be good. Wait. Why is my script not recognizing it? Oh, it didn't have the export. Oh, that's a bug. That's a pretty serious bug. Yeah, so I think my code, my evaluator function expect this function to be exported so that it can run, but this was not the case. Let me add a note here. Export. That's a little bit unusual. So that's definitely one bug. Let me try to run this again. Okay, so after it added the export, now we have 100% match. So okay, interesting. So the code did work, but there's a bug. So I have to update my rubrics for this case because I've never encountered this error. So let's see, missing export. Let me see if my prompt was clear enough. Yeah, I think my prompt was clear enough. You need to import it, so that has to be exported, right? Yeah, it has to be exported. I guess I could have provided an example of how this file would look like, but then this is how this task is set up. So other models doesn't seem to have this problem. Missing export, well, I think it's pretty serious, so we just give minus 0.5 rating. So yeah, so I have to update the rubrics for this test to encounter for account for this new type of error. So yeah, let me update the rubrics. Okay, claim Markdown one. Okay, so it did work, but let me see if the code was short. No, it's not very short. The code is actually quite long, so I think it would get a 9 out of 10 and then minus 0.5 at least for the export statement. So it's 8.5 first, and then I don't think it's particularly verbose. Yeah, so we'll just do 8.5 for this task. That's a lot of thinking though. That's very slow, so a lot of thinking. Anyway, so that's 8.5. Let's move on to the next task. Okay, so this third task is playing MDX, which is a difficult task. Again, let me just run the task first. Yeah, I should really make this like asynchronous and parallel so that I can run all of them in the background. I think I'll do that maybe tomorrow. Okay, so this is now running. Now we can see what this task is. So this is basically a other version of the clean markdown. So in addition to all the requirements from clean markdown, like unwrap code block and unwrap links and remove tables, they also have import statements, so things like this, and horizontal rule separator. So it's a harder version of the previous task. So given this sample input looks like this, quite long, we expect the model to give a sample output like this. So this is the full prompt, and we have the rubrics here. You can see the rubrics also very long because there are different cases of missing stuff. I think given how long the previous task took, this is gonna even take even longer. Yeah, potentially I think it's so long that you know, any kind of network error or some error with open router will just make the request error, right? So that's not very good. Yeah, so this is actually very long. Is there like a time thingy here? Oh, generation time here. I think this means 300 seconds. So yeah, that took 5 minutes to generate. So this took 300 seconds and 5 minutes. that's like very slow. Oh, okay. Oh, this one is actually much faster. Okay, so the thinking is not okay, so now I understand. So the thinking is not actually like uniformly long. It can be faster. So fast thinking. Okay, interesting. So this one, despite being a more difficult task, it actually thinking is quite fast. Yeah, that's interesting. So only 6,000 thinking tokens consumed. Let's see the reasoning, right? Okay, it's still quite long, but I think it's a bit shorter than the previous one, right? So let's try this out. Model response. Yes. Yeah, so this time it has the export. So yeah, previously it didn't have the export. Oops. Yeah, I'm gonna move all this evaluation function into my app as well so that I don't have to do all this. Now it's a little bit manual. Okay, so we got the response. It didn't match and didn't match with 6 divs. So if you look at the code output itself, we can see the half import statement, half of the component. There's some new lines, and there's some dangling components here. So basically some new line errors, import and components. Yeah. Okay, so that's a pretty standard response from a model. So let's try to read it. So we'll start with this one. I think I have one new line issue. We have leftover components and leftover import. So that would be 9 minus this is 0 0.5, 0 0.5, that's 8. And then one new line issue is 0 0.5, so that is 7.5, right? Yeah, 7.5. So that's kind of like middle of the pack kind of situation here. I think for this task, each model is given 2 tries. Let me check my evaluation criteria. Yes, so each model is given 2 tries for this task. So we'll be running it again. Oh yeah, so anyway, so it's a good chance to see like how much variation there is for the reasoning token count. So this run took 6,000 reasoning tokens. Despite being a more difficult task, it took less reasoning tokens than the previous task. You can see here very clearly. So this was a simpler task and this was a more difficult task, and yet the reasoning token difference is like reverse. So if let's try to run this again and see how much token we can get. I'm gonna make some notes for myself to improve this, because I noticed there's a lot of new models that are like very slow to evaluate. So I'm gonna need to make this eval process like asynchronous and run in the background. So that I can run like multiple tasks at the same time and not get blocked like this. Yeah, I think previously it wasn't a problem. Before the reasoning models came out, my app 16x eval actually predates all the reasoning models. So when it first came out, I didn't have this problem, so I can just run them pretty fast. But since the reasoning models came out, I think this is getting longer and longer to run, so I have to make them asynchronous. Let me mute myself. All right, it's still running. Okay, let's take a look at how the existing models scored for this task, right? So this is the MDX, clean MDX, which is a difficult task. You can see the models are no longer getting a perfect score. I think only Grok 4 got the perfect match, which is 9 out of 10. I don't give 10 because I'm Asian. So the max you get is 9. It's to account for like some novel approach or some really wow factors. So far I haven't seen any, so the highest is 9. And all the other top models get about 8 to 8.5 with some minor errors. And I think the open source models are generally around 7 to 6.5. Yeah. This is one particular round, particularly bad round for Sonnet, only got 6. But I think in the other run, Sonnet did pretty well. So yeah. So I think previously, the previous run, GLM-4.5 got 7.5, which is I think pretty good for this task. Yeah, higher than Kimi K2 and DeepSeek V3.1. Same as Quentry Coder. Okay, so this one has finished 8,000 tokens, so slightly larger than the previous run, which is 6,000 tokens. This is only for reasoning token. And let's see the output. Okay, so I'm gonna create a new file, GLM-4.5-2.ts. Oops, this is a folder. GLM-4.5-2.ts. VS Code on my script. Okay, that didn't go very well, so looks like some text was removed. yeah, some text was removed, and there are still leftover import. I think this is part of, I'm not too sure what this is. Let me take a look at input. I don't even know what this is. Oh yeah, this is part of the component. Yeah, so part of the component. So import new line problems, leftover component. This whole component is leftover. So yeah, so this is gonna get a lower score than the previous one. So basically text removed, and we have leftover import and components, and we have one new line issue. So that would be 8 minus 1, which is 7, and then minus 0.5, which is 6.5, right? So that gives the model 6.5, which is almost the lowest score. Yeah, so that's the end of task 3, right? So task 3 we get oh sorry, here task 3 we got 7.5 for the higher rating. I think it's what I would expect from this model. Yeah, so that's task 3. Score is 7.5. So let's move on to the fourth task, which is benchmark visualization. So this is also a difficult task that tests the model's ability to create visualizations. Again, let me just run it first. Okay, so now it's running. Let's see what this task is. So I'm gonna go to model benchmark visualization. Okay, so it actually make it go to the browser. So this is a task to test the model's ability to generate visualizations on benchmarks. So the model will be given a JSON file of data, and then it's gonna generate a visualization to visualize the data, like this one. So the data contains benchmark data for two different visualizations, sorry, two different benchmarks. So you can see this is the JSON file, and these are all the different generations by different models. I think the best ones are from Sonnet and Opus. So they have this side-by-side visualization that allow you to compare the relative performance of the same model for two benchmarks. So you can see like if the model is doing very well for one but doing poorly on the other, so that will be a problem for the model. Yeah, and then on the bottom end we have models that didn't do as well, like I think this one is not particularly good, and let's see, this one, the color is very bad. And then this one, horizon alpha, very hard to read. So yeah, so basically different models will generate different visualizations. This Qwen3 model was particularly bad. Yeah, so this is a very interesting task to test the front-end skill of the model. So I think only Horizon Alpha, the only two models that give dark mode are Horizon Alpha, and the other one is GPT-5. Actually, there's another one that gave dark mode. I think, I don't remember which one, but yeah. Okay, so this task has finished. We have 3,800 thinking tokens. And Okay, so let me copy the code out and render it. Okay, my computer is lagging a little bit, I don't know why. Okay, so we get this interesting looking visualization. I think the chart is just very short. It's not because of my screen, it's just very short. It is a side-by-side comparison, but the colors are the same, so okay, I guess that's still okay. Yeah, I don't think it's particularly good, but I don't think it's particularly bad. At least it's a side-by-side comparison, so I can compare like for the same model how different is the performance. Okay, so let's see. We have side-by-side visualization without labels. Yes, we have 8.5, no labels, none of this, no labels. I don't think it's particularly visually pleasing. Color choice is okay. Yeah, so it will just get a very baseline kind of score of 8.5. Nothing special, but nothing particularly wrong. So yeah, so it's gonna get an 8.5, which is a pretty high score for this task. Yeah, better than Quantry, right? At least better than Quantry Coder. Okay, so I think I'm slightly behind schedule, so let me move on to the next task. So the next task is folder watch fix. This is a pretty standard task. Try to run this. So this is a task on Vue.js and TypeScript. Basically, it's asking the model to implement a feature, a small feature. I think the challenge is mainly in the context. So this is the context. That is a very long TypeScript file. So yeah, so the model need to find where to add the code in order to implement this feature, and we need to evaluate whether the model actually only show the relevant code and did not output the full code. So this tests the model's ability to follow instructions. So yeah, it's mainly a task to test the model's instruction following capabilities. And I would expect all the models to solve this task correctly, right? So that's why this is only a normal task. Let me see the ratings for this task. Yeah, so all the models did really well. I think the only problem is the verbosity, as in whether it output the full code or just the changed code. So that's where the models will lose some points. Okay, so this one is surprisingly fast as well. Let's see, right? So this one, okay, so it did have the keywords that I'm looking for. So this means that the feature was implemented correctly, and it's actually pretty concise. I'm surprised. It's actually a very concise response, only 1000 characters. Yeah, I think it would be similar to the top model performance actually. Give a concise response, and also added the extra logic, right? So if you have extra logic, I think the number of strings match will be 6 out of 7 at least. So this one got 6 out of 7, so it definitely had the extra logic. So that would be 9 plus 0.5 plus 0.5, so 9.5. Oh, that would be the top scoring model actually. Okay, that's pretty interesting. So very unexpectedly, we got the top score for this task. Okay, so the previous task, the score was I think 8.5. Yeah, previous one is 8.5, and this one is actually 9.5, which is pretty unexpected. So I mean, I guess that means the model's instruction following capability is quite good, and it can actually handle normal tasks very well. Yeah, so that's a good sign. So it's actually getting better and better. So the next task is TypeScript Narrowing. This is a uncommon task, and a lot of models are struggling with this task, right? So let's see how well this does. Okay, so this task is very uncommon because it has a concept in TypeScript called type narrowing. So basically, the code has a bug that doesn't allow it to compile. So there's a TypeScript error here, and the models need to fix this TypeScript error by using type narrowing techniques. So there are different ways to solve this, and there's different scores given to the different ways to solving it. So a working method without using the in keyword will get 8, and then the suboptimal method of using the in keyword will get 6, and there are other bunch of other components. So these are some examples. Like if you use the in keyword, it works, but it's like not very optimal, not very elegant. And then there's also another way to solve this without using the in keyword. I guess this is still using the in keyword, but it's in a different way. Yeah. Let me see. Yeah, so I guess this is the better way, using a discriminated union. So yeah, so this is a better way to solve the problem. And then anyway, let's see how well our model does. Okay, so this one is actually pretty fast, right? So all the later tasks are pretty fast. I wonder if we hit some bug just now. So let me create the GLM-4.5 TS. Okay, so this is the first attempt, so let's make it 1. Each model I think get 2 attempts for this task. Okay, so this doesn't look like it's gonna work. Let me try. Yeah, I've seen enough runs that I know this is not gonna work. Yeah, it didn't work, so this one didn't compile. Wrong. 1. Okay, so that's the first try, didn't work. Let's try the second try. For this task, actually, only very few models got it right, I think. Sonnet, GPT-5, GPT-5 High, Group 4. Yeah, so all the top models I think got it right. Oh, no, sorry, not this task. Not this one. Wrong task. TypeScript narrowing. Okay, here. Yeah, only Opus and GPT-5 High got it like 100% right. And then the other models, like I think Group Code Fast provided one solution that works, and then Sonnet 3.5 and Sonnet 4 provided two solutions, but only one worked. So all the other models, I think, basically similar. Yeah, I'm not sure why this one got 8 and this one only got 7.5. I think maybe there's something wrong here. I have to investigate. Anyway, all the other models are pretty bad at this task, so yeah. No surprise that this one got it wrong. Also, yeah, so this one looks like it's using the in keyword, so it might work. Let's try this out. Okay, so compiled successfully, that means this one actually works. Yeah, let's move it here. Okay, so it does use the in keyword to get it right, so that will give a 6 out of 10 score. Let me check the output. Yeah, so the only solution is that one, and this one gets 6. Okay, that's it for that task. We move on to the final task. Okay, so the last task is a very simple task called Next.js to do add feature. So let me just run it. Okay, let me run the I think the concise prompt works for most models, so let's just run that. Yeah, I just want to have different prompts for different models, but I think the concise one works the best. Yeah, so yeah, this is a very simple task to add a created time for the to-do items inside the to-do app. So I think the model should handle this pretty well. It's also the task to test instruction following, because the model needs to output a very concise output, otherwise it will get penalty for verbosity. Yeah, and there's additional rating for concise response, so mainly to test how concise the output is. Let's see. So I have an automatic evaluation script to check if it has certain fields and check for the length. I believe this one is 8. That means it must have outputted some full code. Yeah, so basically it outputted the full output instead of outputting just the code that needs to be changed. So I got an 8 out of 10. So yeah. Okay, output full code and 8 out of 10. Okay, that's interesting, because in the previous test they actually followed the instruction but didn't do it for this one. Anyway, that's all the tests. So let's take a look at the final result. Okay, I don't think it's particularly good. Yeah, let me add a few models to compare. In Kimi K2, we already have Quantry Coder, so I think that's what people care about. In terms of overall rating, I think it's quite low, better than Kimi K2. This is the old Kimi K2. I'll be doing the testing for the new one tomorrow. This is the old one, 0711 model. It did better than the old Kimi K2, but did worse than Quantry Coder. If you look at individual ratings, I think it's surprising that it failed on Tailwind task. But it's also surprising that it was managed to solve the TypeScript narrowing task, right? So on some tasks it's like better than other open source models. So you can see here, for this particular TypeScript narrowing task, it's better than both Quantry Coder and Kimi K2. But for this Tailwind CSS task, is worse than Quantry Coder. And then yeah, so basically so I think Quantry Coder did better than GLM-4.5 on 1, 2, 3 tasks, right? And then GLM-4.5 did better than Quantry Coder also on 3 tasks, right? So 1, 2, 3 here. So it's basically like a tie if you consider like a number of tasks that models did better, right? Because I would say it's like very similar to Quantry Coder performance. I think you have to restrict the reasoning token, maximum reasoning token, if there is such option. Let me see if there's a yeah. So basically you want to either disable the reasoning inside your coding agent, like here you can disable this. I think by default it's not enabled, and then if you enable it, you want to set a budget, right? Like 6,000 is okay, I think. Yeah, so basically you want to like limit the number of reasoning tokens, otherwise you will get very crazy crazy reasoning token counts, like this case where it did 18k reasoning tokens. That's very long. So you need to kind of limit the number of reasoning tokens for this model, otherwise it can think for very long. Yeah, I think that's all the testing I want to do for this model. It's exactly what I would expect. It's like middle of the pack, similar to Quantry, better than Kimi K2. So yeah, exactly what I would expect, and not very surprising. It's okay, but it's not the best. So it will be like somewhere here, right? Slightly below Quantry Coder and higher than Kimi K2. I'll be updating my my evaluation bar chart after this stream, maybe tomorrow, and then you'll be able to see the new results, right? I think if it's like $3 per month for the subscription, it might be worth it to just use this, like if you are budget conscious. But otherwise, I think Sonnet or even group code fast it's just better than this model, right? Like there are much cheaper options like GPT-OSS 120B. I think underrated. Group code fast, also pretty good. Yeah, I don't think this is gonna be a particularly cheap model. I haven't calculated the cost, but I don't think it's gonna be cheap because of the reasoning tokens. we can calculate the rough cost here, right? So for this task, it alone is already this is $0.036. That means it's 3 cents, right? So for this task is already 3 cents. And for this task is already 1 cent. So so yeah, it's definitely like not very cheap. I would think it's around 3 to 5 cents, but I'm not 100% sure. Yeah? Okay. Anyway, that's all I want to do for the evaluation. And tomorrow I will be doing another evaluation for the Kimi K2 0905. So this is a new variant, or new version of Kimi K2 that just came out. I will be testing it tomorrow. So if you want to see how well this does, I'll come join the stream tomorrow. And I also try to improve my app so that I don't waste time waiting for the model response. Yeah. Thank you everyone for watching, and I will see you tomorrow.